All right, 6-4, part 1, just introducing the sine and cosine functions and doing 2 examples using transformations. So this was a snapshot of what your notes were supposed to look like. So at this point, you can pause the video, copy this down, or you can watch me put it together. So I highlighted the ones that we'll use for our parent table, but I put all of these special angles in my table for understanding why it takes on this wave that it takes on. Okay, and these are gaps here. These are the pi over 12s, just so that I can label my uh, x-axis in equal increments. So you don't want to include these, but I have them in here so I again, can label my x-axis proportionally. Okay. All right. So these are the pi over 12s. I'm just leaving gaps, and they're the ones that surround the quadrantal angles. These are the pi over 12s, the ones that surround the quadrantal angles. Okay. All right. And this guy up here, that's good. Yeah, this guy up here. Okay. So make a table. We filled it out. So these were just practicing our quiz questions. So there they all are filled out. There they are all filled out. And then I had you turn your paper sideways and we plotted our points. And here you can see the pi over 12s. They don't get marked. But to keep the increments all equally spaced out, the marks on the x-axis. The only ones that I want to include when I show my transformations are these ones. The ones that give me a 0, 1, or -1. Those are them. And those are the guys that are highlighted in pink. Okay? So to get the so this is one period. So then we went on to say this is one period is sine of the sine curve. It's a periodic function. So its shape is going to repeat every 2 pi units. And I also was estimating that radical 3 over 2 is 8600ths, radical 2 over 2 is 0.71. So if it repeats every pi units, I can continue this wave every 2 pi units. So I made another wave, another cycle on the other side of the y-axis because it's an odd function, and odd functions reflect in the origin. Okay? All right. So that was a sine curve. That's how you could put it together, and it never stops. It just makes this wave for an infinite amount of time. It goes on and on and on forever. So its domain is all real numbers. If it goes on and on for always, it goes on forever for always. So we say all real numbers is what I can put into it, but it only bounces between -1 and 1. +1, -1, +1, -1. So all the numbers in between positive and -1 are the output values, the range. So these periodic functions, or this periodic function, has an amplitude, it has a height, like how tall is it from the horizontal axis? It's just 1 unit high. Okay, and that amplitude is going to change as we do transformations. It can be a half a unit high, a quarter of a unit high. It could be 5 units high. It's just going to depend on what the value is in front of sine. This was my original, this was the one that we had in the notes on what was it, Wednesday, January 13th. And then we put together, oh no, and I just added this. I added this. This is the parent table. So I gave you the parent table when we did an example. So here it actually is after that whole lengthy, crazy, tedious table that we'll never do again. There it is. It's only including the output values that give me 0, 1, and -1. And how do I get those? By putting in the angles that land on the axes within the unit circle. And then the cosine, we cut to the chase. We didn't do the tedious part, and we filled these in. And we came up with these values right here, just putting in the quadrantal angles. And you get a 1, a 0, a -1, same thing. Cosine and sine give me the same thing. So these were the ordered pairs that we used to graph. And here they are. And these guys have the same shape. They make the same curves, except they're just shifted over. They're a shift. They're each a shift of each other. So we continued another period. I said cosine is an even function. That was from the 6-3 notes. Cosine's an even function, so he's going to reflect in the y-axis. So if I've got this guy, then I can flip him over and get that guy. And then he's just going to keep doing that forever and always. So we're always going to graph two periods. So you know you have two periods of cosine when you've got this W. I mean, you could say you have two periods of cosine and not have a W. You can make it look just like sine. But for us, for now, we're going to make it look like a W or maybe an M, depending on if the transformation is reflecting it in the x-axis. So it might be an M. And then I went on to say his domain and range and amplitude are just like cosine. Okay. All right. So I did an example. So again, you guys have the ability to pause this video, rewind it, whatever, or not even look at it at all. So here's my example. I did add this, that you need to graph two periods. I think I mentioned it. Actually, I think I did write it. I deleted it. I'm going to start with the parent table. And that is just plugging in those angles that land on the axes. So I try not to memorize too much. Like I'm not going to memorize a table. That would be ridiculous. But I know my trig ratio values. So sine of 0 is 0. Sine of pi over 2 is 1. And so on. So I've got those memorized for sure. And then the transformations, I think I glanced real quick right here with you guys. Today, or for this first assignment, it's just going to be looking at A, H, and K. For this assignment, just A, H, and K, although there was the last, one of the questions had a B value. And if so, that means if X has a coefficient, it has to be factored out of the X and the H value. And then you multiply the H's by that reciprocal. So we'll talk about this guy tomorrow. Tomorrow is January 15th. So same thing, multiply the y's, add or subtract to the x's, add or subtract to the y's. You add or subtract to the y's after you multiply whatever it is to the y's. All right. And I just went past a different assignment. That's something else. So don't do those problems. I mean, you might be doing some of them, but I think I'm deleting or maybe adding, but I think it's deleting. So, multiply the y's. And then this is really x minus positive pi. Remember, it's always in that form, x minus h. So if it's still minus, it's because we plugged in a positive number. So I'm going to add pi to the x values. So adding pi, just a side note, just in case, if you're in this class, you should be okay with coming up with 5 pi over 2 without me showing this, but just in case, here it is. So I'm adding pi. Okay. So now I'm going to label my axes, my x-axis, and since I went to the right, I moved to the right, I'm going to move my y-axis over. I'm not going to need too much of the negative. So I'm not scrunching this guy, scrunching it horizontally, meaning I'm going to make it go really fast. This is just a normal curve, just shift it over. Normal curve meaning parent curve. So I've got my y-axis going, let's do this, from -2 to 2. And here I go. I'm going to plot. Pi 0. Oh, I didn't label. Hang on a second. I got to label this guy. This is pi over 2. This is pi. And I don't even have these guys, or I don't have this guy in my table, but I want to keep the same momentum. I don't want to mess up my markings. I always want my markings to be the same distance from each other. So 3 pi over 2. So I plot pi is at 0. I plot, let's use a different color. Pi is at 0. 3 pi over 2 is at 2. 2 pi is at 0. 5 pi over 2 is at -2. And 3 pi is at 0. So this is one period of sine. It's that backwards S on its side. And now I'll graph a second period. Knowing that it's periodic, it's just going to repeat this shape. So I'm going to continue marking my x-axis in the same manner by pi over 2's. I think that's enough. So it's gonna dip down at pi over 2. It's gonna go up to 0. It's gonna come up at negative pi over 2 up to 2 and end at pi. And if you want to do more than 2 periods, that's fine. Just don't get sloppy labeling your axes. So some students just graph it on a calculator and then they just go boop, boop, brrr, because their calculators are not labeling the x-axis correctly. And so they don't know how to label it. So you're not going to get points. It's just like that check for understanding we did back in November with the exponential and logarithmic curves. You need to include your parent table. And I need to see that you apply the transformations. If you just give me some crazy curve with no labeling on the axes, then I know you most likely use a calculator. Or you just knew it was supposed to be something like that and you just randomly did something like that. All right, so the last one, I did not get to this one in the notes. This is a cosine curve with 2 different transformations. Well, I guess you could say 3. This one's going to smash it. It's going to make it not so tall. This one's going to turn it upside, or it's going to reflect it. I won't say turn it upside down. It's going to reflect it, so it's going to be the M shape. Cosine is always a W, but if it reflects, it's going to be an upside down W. And then this is a K value, so it's going to lift the horizontal axis up. Or it could lift it down, but this one's going to lift it up because it's plus. So I'm going to give myself the parent table. So keep those straight. Don't think you have to memorize cosine's table. Gosh darn it, I can't pick up my eraser. Don't think you have to memorize cosine's table versus sine's table. If you know your trig ratios, you're doing well on those quizzes, then you should be able to put this together. You just use the quadrantal angles, the 90 degrees. Whoops. The 180 degrees, the 270, and I say cosine of 0 is 1, cosine of pi over 2 is 0, and so on. And then I'm going to apply my transformations. So this is really 2 transformations, but I'm going to do them at the same time. I'm going to multiply the y's by -1/2, but the negative it's just going to automatically reflect it. I think you guys understand that. I think you do. But if not, let me know. We'll talk about it. And then the +3, he's not wrapped up with x, right? There's a difference. He's not wrapped up with x. If he was, then I'd have to subtract 3 from the x's. He's not. He is a k value, right? So he's this guy. He's hanging outside the parentheses. So get him to add to the y's. So I'm going to add 3, and I get 2.5. Or you can say 5/2. I'm going to say 2.5. I'm going to add 3. I'm going to add 3. I'm going to add 3. Add 3. And those are my new points. So the x values didn't move at all, but this horizontal axis moved, which is kind of weird for some of us, especially for starters. So let's draw our axes. So it's big points for getting the axes labeled. I'm going to drop my x-axis down a bit. I'm going to put my y-axis right in the middle because this guy didn't shift to the left or the right. And I'm going to just label like I would the parent curve. Okay, and I'm going to label my y-axis 1, 2, 3. And then I got to have the half mark. So up at 3.5, up at 2.5. And just for fun, make them all halves like that. Or not. Okay. I can't get my pencil to put anything down. Plot your points. So I'm at 0, 2.5. Then I'm at pi/2, 3. Then I'm at pi 3.5. And then 3 pi/2, 3. And this is actually where you could say your midline went, your horizontal axis is now sitting right here. Gosh darn it. You don't have to draw that in, but I want you to realize it because we're going to talk more about the amplitude tomorrow. So what else do I have? 2 pi is at 2.5. Okay, so here is one period of this cosine curve. So I'm going to graph the other one. I'm going to continue this pattern. So I will mark my x-axis on the other side, like the same way. He's still an even function, but mostly we want to just say he's periodic. He's going to continue this curve. Because at one point he might not be even, depending on what the transformation did. So this guy's still going to reflect in the y-axis. That's all I'm trying to say. So he's going down, reading it right to left, down, going up to the midline, up, down to the midline, down. So he's going to go back up to the midline and then go all the way up to its highest point. So negative pi/2, I'm going to bring you up to your midline. Negative pi, you're going to go up to your high point, which is 3.5. Negative 3 pi, back over 2, back to the midline. And at negative 2 pi, you're going to go back to 2.5. And so he's the upside down W, which to me is still a W, but you can say he's an M. All right? All right. So we're going to do more with this. We got to talk more about domain, range, amplitude, periods, really mostly just periods and amplitudes. The domain is always going to be all real numbers. Anytime a parent function is all real numbers for the domain, it's not going to change. The range is going to change, and the range on this guy for sine and cosine will be determining the amplitude, or play a part of what the amplitude is. Or maybe I could say it the other way. The amplitude is going to play a part in the range. Anyway, they go together. All right. That's it for now, and I'll see you tomorrow.